Good morning, viewer. Bienvenue here. Here's the breaking news and most amazing too. Viewers, you might guess it had been tough to extract saliva from a mosquito, and you had be correct. Yet, because mosquitoes spread diseases via saliva, it is critical to sample and study. But Anita Saraf does not collect a mosquito split herself. It gets delivered so she can discover its scientific secrets. Saraf is the director of the mass spectrometry and analytical proteomics laboratory at the University of Kansas, where she uses shotgun proteomics to analyze biological samples, basic science that underpins many drug therapies. Collecting saliva from these mosquitoes is challenging due to the small sample size, which is a common limitation in such experiments, she said. Our collaborators with the USDA Agriculture Research Service put the mouth of the mosquitoes into a tube, then stimulate a salivation and collect the saliva. Now, with a new 2-year grant of $250,000 per year from the US Department of Agriculture's National Bio and Agro Defense Facility, Saraf currently is analyzing these samples of non-infectious mosquito saliva in the fight against arboviruses, the term for viruses spread by arthropods like mosquitoes. This includes West Nile, yellow fever, dengue fever, Japanese encephalitis and other viruses that can harm or kill people, animals and planets. The USDA has an interest in veterinary applications for the findings, but Saraf's work could underpin therapies for people as well. The USDA wants to study how the virus affects the immune system and changes at the molecular level, particularly the proteome of mosquito saliva, Saraf said. When a virus infects a mosquito, it alters the proteins and other basic components of the mosquito, similar to how malaria affects its human host as it progresses through different stages. Saraf's proteomics analysis of the saliva succeeded because of using very efficient sample processing methods in tandem with shotgun analysis. This approach is effective with very low volumes or amounts of sample, like for instance hard to obtain mosquito speed. At our mass spectrometry core at KU, we use shotgun proteomics, nanoscale liquid chromatography coupled with tandem mass spectrometry or NLC MS, which requires only a minimal amount of protein in the nanogram range, making it dull for these types of biological samples, Saraf said. The sensitivity of our setup is crucial because without it, we would need much larger protein quantities. Once we receive the saliva samples, we handle all the sample processing, preparation and digestions to make them ready for mass spectrometry analysis. We have the latest equipment and a special setup which gives us high sensitivity, putting us at the forefront of this research. Bow down, madam, bow down. Behind this exclusive report,